what FAIR can be applied to. Oh, thanks. Okay. Okay. Yeah. So here I have some more notes together with this. So while we already published a report on the ML lifecycle. The white paper is still an ongoing effort, and we invite everybody in the IG, and of course people who might be thinking about joining the IG, to go to the link and provide your thoughts on that. This is where we are at the moment with aligning the FAIR principles to each step. For today, there's not really a specific activity that will happen within this session, but we invite people to contribute asynchronously on that. There's tables in that document summarizing the different stages of the life cycle and mapping these to individual principles, more specifically with which principles fit those stages. There's a second table as well where a model is presented in a more detailed manner based on the life cycle we created during the hackathon. And what we want to do is reapply the identified principles to that model that we put in that second table. We're hoping to determine for each step in the life cycle those really the final elements. So we want to go as far as possible to determine those final elements that we need to identify and then try to match the FAIR principles on that. This is happening across various steps and in the consolidation of the work we've done since March 2023 to where we are now, working during the plenaries and also asynchronously. The ML lifecycle in Zenodo, it presents a better way for us to first identify and document in detail which elements that we feel are applicable in each step, and this we feel is just a start. This is where we started everything towards the white paper. So this is just one step in getting to the white paper. So all contribution from the community through the previous plenaries, the hackathon, and everything represented in the document for the notes there. So that's really represents where we are right now. And yeah, so we really invite everyone to come in, critique, suggest. And the next step is to hopefully consolidate all this into a single report, a sort of a preprint for the first outline of the white paper, which we had hoped we would have at this point, but this seems to be more likely to be out in early 2025, hopefully before the next plenary. Yeah, but in the meantime, we invite everyone to contribute to that. So I'll just go through and I'll take your questions afterwards. So one of the things we're doing is collaborating with Skills for EOSC, which is actually where most of my work is. I'm working with Skills for EOSC, leading one of the work packages there, which is looking at professional networks for lifelong learning. So setting up and bringing stakeholders together in data stewardship, in FAIR and AI, and health and technology research, also open science communities. And one of the tasks we're doing is trying to one of our outputs is going to be a top 10 FAIR data things for AI. And at the plenary in Gothenburg in 23, we decided to collaborate with, agreed with FAIR4ML to collaborate. So what we've done so far is, I've been part of the hackathon here. So we created the ML lifecycle, and then we took that into Skills for EOSC, where we applied the FAIR implementation profiles, and worked with FAIR4ML members and other researchers around Europe to create to come up with items that we can use in the Delphi survey, which a Delphi survey, if you don't know, is a multi-round survey where we put out items and people vote on them. We take in back, look at the consensus, put it back out again. And then we have a third round where we have in-depth discussion to finally agree on those things. So the items we came up with through literature review. We worked with the IG and other researchers to really define those, see if they make sense. And then we had a final 20. We put that out in the first round of the survey. We've got that back, and some of them have reached consensus, so they will go straight into the top 10. And some of them didn't make it; those fell out. And some of them were in the middle. Those goes back in the second round for revoting. And we also got some suggestions from researchers, which we have included in the second round, and that's now closing. And we expect to have this top 10 thing, FAIR for data things, FAIR data things for AI, which we will change the name because as Dan pointed out, I mean, the FAIR data doesn't really fit exactly with what we're doing. And what we're going to do with the output from there is then feed that back into the white paper again. So we're just kind of supporting each other and trying to define as far as possible how FAIR implementation works with machine learning. Yeah, so that's it there for me. I think if you have any questions, I will do my best to answer them at this point. Yeah, sorry.
Okay, Hugh Shanahan, Royal Holloway. With the Delphi study, you kind of have an initial list of top 10 fair things, and that's sort of like your seed point. So far, have you found with after the first round, has there been much change? Have new ideas appeared, or is it staying fairly stable or whatever?
Thank you, Hugh. So together with the literature review and input from researchers, we had an initial list of how much, I think it was more than 35 principles we came up with first, not principles, but items for the survey. But we whittled those down to 20 based on consultation with the members of the IG. So we came down to 20, and those we put out in the first. So we have so 5 of those 20 reached consensus, and we asked in the survey for researchers or participants to suggest, and we had quite a few, like probably 45, but a lot of those were kind of different wordings for what we already had. A lot of those were we could combine into one, and some of them didn't really fit within the remit of FAIR. So we fed back. We have a final 7 from those suggested ones, new ones, if I'm answering your question, that we got from the community, which we fed back into round 2. An interesting thing, if I may say so, is that what we found is a lot of researchers were kind of pushing for a little bit beyond FAIR into reproducibility and ethics. There was quite a strong feeling for that. So we felt we had to include that as well. That's also welcome. I'll pass it back over to Dan for TF2 and any other comments, if you have questions yourself.
Okay, yeah, so we'll let's go on then to task force 2. Sorry, and this is I will admit up front that this will be a little bit awkward because I actually have not been active in task force 2. I've also been active in task force 1, but we just didn't get any of the task force 2 leaders that were able to come here. So I'm going to present this for them, and hopefully I can try to answer questions, but we'll see what happens. Okay. So yeah, so task force 2 is basically looking at metadata for machine learning related artifacts. And that's, I guess the part of this that's really new is mostly actually the machine learning models, but there also is metadata related to the training data. And the metadata for training data may have some specific characteristics that are different than metadata for data more generally. So that's also part of the question here. And so the work around metadata for training data. Sorry, let me just look at my notes for a second as well. So the metadata around the work around metadata for training data is being done by the Croissant group that's part of ML Commons, and the work around metadata in general for the software that's training and optimizing the model is being done in part kind of by this collaborative group that's coming from the Code Meta group, and Code Meta is a group that's basically metadata for research software. Bioschemas and NFDI for data science, which I mentioned both of earlier. And then if we think about the models themselves, we think that there probably is domain-specific metadata for the models. And that's really the main kind of thing that's happening. In the metadata schema version 0.1, and I'll talk about the versions in a minute, there's a special class for describing evaluations, for example. The deployment of a model is not very well defined yet in the metadata, so that's one of the challenges that, that the group is still working on. And then the question then again is, are there other things that are really specific to machine learning models, and maybe different cases of where a model is developed or used or deployed or tested or something else where there's specific metadata that would make that would be needed really to make it fair in some sense. And I think we don't really know the answer yet for that. So again, the validation evaluation has been worked on a little bit. Deployment has been kind of started to be worked on, again, metadata for these things, but there may be other things as well. And so if you have suggestions for other things, again, that would be great to hear in the collaborative notes or just here. So then, so the task force then has had two main kind of sub efforts. One of them is to do a crosswalk to look at existing initiatives and vocabularies, and this includes DOME and Hugging Face and bioimage. And effectively, the idea of a crosswalk is how to translate a metadata field in one platform into another platform, either the same field or different fields, depending on how the different schemas or platforms are described. The FAIR4ML schema is basically an extension of schema.org, and again, this version 0.1 has been released, and it is based on feedback in previous sessions. There was I think a 0.0.1 that was initial, and then we got a bunch of feedback from that, and that's what's led to the 0.1. And over the next round, I'll talk about, there's more feedback that hopefully comes in, and then that leads to the 0.2 schema. Okay, yeah, I think that's probably the main things that are here. So work going on, trying to connect it to other schemas, using crosswalks as the mechanism to do that, basically using feedback from the community as a way to see what's missing or what's working or what's not working, I think is maybe the high point here. So the documents that the task force has created are a literature review, was the first one. Second one was actually these crosswalks themselves. So going through one schema, trying to figure out how does it translate into another. And then finally is the metadata schema itself that's being developed by the FAIR for Machine Learning group. And this schema has been basically built by two of the organizations that are part of the group, Inez Data and ZBMed, respectively in Madrid and Cologne, I believe, at least Germany. And so this is then led, again, based on the feedback that we had last time, to the 0.1 schema, which is available. And again, we're looking for feedback on this. And so what is in here is pretty complicated in some ways, but it's kind of grouped in different areas. And so there are questions about funding, about distribution, about how this could be cited, about what license it's under, about people involved in it, whether that's the author or contributor or the copyright holder, information about if the model has been published in some way, the different data sets that it's been tested on or trained on or evaluated on or validated on, and then what kind of overall evaluation has been done. And then some other general characteristics of the model itself. So the challenge here is that in some sense, you can think of a metadata schema as being relatively simple if it's generic, but the more specific it becomes, the more detailed it also can become. And so that's effectively what's happening here, is because machine learning models have a bunch of characteristics that are different than data, there effectively is a need or a desire to be able to describe things about all those characteristics. So again, this is all available on the slides, and this is actually in the schema itself, although not in a visual format. And we are looking for feedback on this. Just to give kind of one example of what this looks like for part of this, and this is the idea is that this is kind of similar to Hugging Face model cards, that you have an identifier, you have a name, you have a version, you have some keywords, a license, something about development, the date that's created, the date it's modified, and then all the other things that were on the previous slide. So it didn't make sense to try to have a text version of this to show, because it's just a lot of text and we'd have to go through pages and pages. So hopefully the visual piece on the previous slide kind of gave you an idea of what the things were, and this is just kind of to show you what a part of it looks like in terms of XML, or effectively text. And there is a link to GitHub that goes to the whole thing. So okay, so where we are then is sorry, where I should say this task force is continuing to do work on crosswalks. And there's an online hackathon that is continuing asynchronously, that if you're interested in joining, you can come in, you can contribute a crosswalk, you can try to validate a crosswalk, you can disagree with a crosswalk, and anything like that. And that's going to be going on until the end of the month, the end of November. Then there will be a new consultation feedback period based on this version 0.1 again, to lead into a version 0.2. The idea is then that consultation and feedback period is both new comments as well as what did we learn from these crosswalks and the hackathon. And then again, yeah, that updates version 0.1. The task force will also build up documentation, website examples, and adoption. And there are these two groups, Inés Data at Madrid, Universidad Politécnica Madrid, and the ML Entori work that's going on at ZBMed and NFDI for data science. So these two groups are trying this out to see, does it work? Is it helpful? And their feedback is part of what is going into this. And so if you are part of an organization that also wants to try this out, that's really the best way of giving feedback. Is it's much more useful to say, I tried this and this piece didn't work very well for me, and it would be better if it was like this, than to just try to look at it generically. So if you have organizations that are interested in doing this, we would love to hear from you about this. And so if you're interested in getting involved in this part, the community consultation feedback, the ways to do that are through the online hackathon, through general comments on the RDA webpage, through comments on the spreadsheet to talk about things about the properties themselves, comments about missing properties on the spreadsheet, or anything in the GitHub repository, like a new issue saying you missed this piece or something like that. Again, all of these links are in the slides, which you all have access to. And I will leave this up here for a second, just because it has the links to the notes in the slides in case you've missed them previously. With this, I will ask for any questions about the Task Force 2 work before we actually then move on to the one flash talk that we have that's remote, and then anybody that wants to speak here. So.
Thanks for that, Dan. So this is David Albert from Johns Hopkins. I'm curious, in Task Force 2 with the schema work, is the end goal that where's somebody going to write queries against this schema? Is there an end goal that there'll be a registry that adopts this? Or, I mean, what's maybe not part of this working group immediately?
Yeah, so I think sorry, I don't know how we're doing on, okay, you're over there. Okay. I think, so the answer to that, I believe, is that That's part of the reason that we're trying to work with all these existing platforms, and the reason that we're asking about other platforms that we don't know about, because effectively one of the challenges with machine learning models is that there's a bunch of places they could go, and there's no really federated search across those places. But if we actually had consistent metadata, then that would be one of the steps towards building up federated search. So I think that's part of the reason kind of inherent behind this is to be able to search either individually or hopefully collectively at some later point. And that's also part of the reason that we wanted to have these stakeholders involved in the working group in some way, is so that we're not going to build up a metadata schema that, well, let's say that, yeah, that Hugging Face says doesn't work for them, or that they're not interested in supporting. So, yes.
President. Hi, I'm Florina Piroy from TU Wien, Austria. So I am part of the group. I'm following it. But my question is, machine learning models, they don't last long. Is it worth to invest so much effort in describing all these steps, because it's a lot of work? I know that I'm trying to implement this also with myself, my students. It's really a lot of work for something which in 2-3 years might not be usable anymore, because the machine learning models, the software itself, is just not possible to run anymore.
So I understand what you're saying, and I don't know that I have a good answer for it. I mean, I think the answer is going to be that there are certainly cases where we do want to do this. There's going to be cases of reproducibility where we may be able to run the model in a container, for example, or in some other preserved way. And we're going to want to be able to reproduce this work that led to some result that we're now questioning, right? And go into it in some detail. So I think there's definitely cases like that. There also, I believe, will be cases where models will show up in society in some way, and they will have some much longer lasting evidence over time. But then there also are these kind of quick research models that maybe are not going to last. And in some ways, I guess I would say that this to me feels kind of similar to software, and that some people are building libraries and applications that they expect to be used by large communities for long periods of time, and some people are writing a script that supports one paper, and they don't think they're ever going to use that again. And so, yeah, what levels of metadata we want, what levels of preservation we want, what levels of reproducibility we want, probably depends on the use case, and we have not worked any of that out yet. So I don't know the answer, but it definitely is something that seems like it would be very reasonable to try to go into when we get a little bit further along. So yeah, I think it's a good point.
Hi, Tomasz Miksa, TU Wien as well. Actually, I have, let's say, comment and question. One is about the modeling the task force too. I have seen like a couple of fields in the bottom of the slides, which were, let's say, specific to the model. Most of them were open text fields, and I think there is still a lot of work basically to try to constrain them, because only then we can make things a little bit more machine actionable. So I think there's still a lot of work ahead of us. Second thing is regarding the timeline, because I understand that the ambition is that we want to produce a recommendation in the end. So part of making a recommendation, you also have to have the adopters. And I understand that, for example, Hugging Face or OpenML, they will say, yes, we like it, and so on. So have they seen that already? Are they saying they like it? Are they making any commitment? We will change our model cards based on that, or this is still this discussion is still to happen?
So this is one that I'm not going to be able to answer completely, because again, I just haven't been involved in this task force. But my understanding is that partly yes. So like Croissant has an example that is very well connected to Hugging Face. So that part does seem to be successful and seems to be definitely leading into something that will be accepted. I think what's happening here, we have had input from Hugging Face and OpenAI. And so I think the answer likely is going to be yes, but there is certainly no commitment. But they are aware of what's going on, and they have not said anything negative about it. So. Yeah, so as far as I understand, they have had involvement in this process, but again, that's not a commitment to anything. So yeah. Sorry, I just wanted to mention back to your question that there was a comment from Graham in chat saying that it's it's worth doing the work for the credit tracking and to get recognition for the people that are creating the ML code and data, both input and output, and also for transparency. So, so just other reasons, but again, whether those reasons outweigh the cost is a different question. Okay, Hugh.
Thank you. So sorry, just also to get back to the first the question that you raised about is it worth the effort? I mean, one problem that could be solved with this is that continually a researcher is sort of saying, I have a data set, I want to apply some machine learning techniques on it. Who's done what on this data set? So you could have a situation where if you have this kind of setting up these types of descriptors, then you're able to find that more easily. And correspondingly, here's a method. What data sets have been run on that, and to test that. So that would because we know that machine learning is basically throwing mud against a wall until something sticks, all right? And what's always much more useful is that meta-analysis of who's done what with what methods, and understanding what works and what doesn't. And that, I think, is a thing which really I think would be really interesting about this. You know.
Okay, any other questions, including from people online? Let's see, another comment from Graham. Graham, I don't know if you want to actually just speak rather than me reading your comments out loud.
Yeah, I was just sort of saying about there's a cost benefit to kind of people's careers that kind of might justify the actual effort you put into it. You may not realize it straight away, but building up that evidence base of your contribution to the scientific effort may be good in the long run for your career. So it could be a personal kind of contribution and cost that you have to put out as a first initial outlay. But I think it's important if we are going to track these components, we've got to do it in a way which we can actually action.
Okay, thank you. Any other comments? Yeah.
Just because this is a topic I spent a couple of weeks ago, some hours looking at Hugging Face. Yeah, this is community driven. So people, they do like to publish their models and the data, and they try to document it somehow. And there is also a lot of effort to tap into that knowledge base, because what Hugging Face has is building a knowledge base of models and data and notebooks and whatever. But because it's so badly described, it's very difficult to extract out of it this an RDF graph, for example, or a knowledge graph out of it. So this is now why it is so difficult, because they don't have a FAIR4ML thing. So we could try to maybe test out whatever we try to develop here on the Hugging Face platform, talk to the people there, here, try this, improve your model cards. I don't know.
No, I think that definitely sounds good to me. We did, I think when we had the meeting 2 plenaries ago, I believe we had a Hugging Face talk in that one. Something like that, so. Yeah. Okay, if there's nothing else on Task Force 2, we should go on to the talk that we have. I guess I should also mention, again, I'm sorry, I'll go back up. Some people have been involved in this for a little while, but it's worth mentioning that FAIR4ML is an interest group, right? It is not a, not a working group, thank you. And because it's an interest group, it doesn't have a deadline, and it also doesn't have requirements in the same way. So we're kind of trying to treat the task forces almost like mini working groups in some way, where they're actually trying to work towards something on a deadline. But they're not actually quite held to that by RDA, and so things can slip a little bit. Yeah, so I don't know. I mean, maybe RDA needs a hybrid, something else that's different, but that's probably a tab discussion. Right. Okay. So let's go on. So Lynn has a remote talk. Are you there, and can you speak and share your slide? Let me try to stop sharing here.
I can speak and see you. Can you hear me?
Yes, we hear you.
All right, so let me try to share my slides. See if that's going to work.
Okay, that worked. Let me give me a second just to try to figure out how to expand this here. Okay, so I think we see you as well as we're going to.
Okay, good. Thank you very much. So my talk about challenges for FAIR4ML, and especially I work in reproducibility. So my talk is heavily slanted towards the goal of reproducibility with all the possible definitions and the measurements that it can be. And also, so I wanted to also add a little bit to what the previous person has been asking about is it worth doing this? And I work in the scientific world at the Department of Energy National Lab. That's going to be my third now. And especially we have like very large instruments like National light source and synchrotron and applied photon source. And these instruments have detectors. And, at Brookhaven, where I was previously, there's like 25 detectors, going to go up to 60. And there's a very large team right now, which is trying to apply a machine learning program to simplify the operations that they have, especially and it goes all along the spectrum. It's not just collecting the data, analyzing it, helping calibrate the detectors. There was an effort specifically trying to classify the images, which is a pretty basic machine learning problem. But when you're trying to apply it to images that you cannot you cannot crowdsource the difference between a cat and a dog, because you're trying to determine if the image was actually a blob, or if it actually shows something, or if the instrument was actually working. And even when the instrument is working properly, half of the images have to be discarded. And this is a task that the scientists and usually delegate graduate students to do. And they were trying to automate that with machine learning. And in cases like this, the use of machine learning in science, it becomes really, really paramount to have metadata, and not just metadata, but specifically tools that allow you to extract the metadata about the experiment that you're doing. And in this particular case, it would be the machine learning metadata model that you're trying to apply. So schemas like we're trying to put together in the FAIR4ML machine learning effort at RDA are the basis for developing such tools. Before we can get the tools, we need to get, schemas that are that everybody can actually agree upon, or a large number of people, and that are extendable. So then tools can be applied using with the metadata schemas. And once we have the schemas, the metadata, then, and maybe not all parts of it will be applicable, but then with the tools, you can actually, the scientists can actually use it in their experiments, and it helps them out. And they will use it if they see a benefit. The schema by itself is never sufficient, but schema plus tools, and they can see that they can, they can classify their images as to, what needs to be kept and what needs to be discarded in a much faster than having a person looking at each images as they're being produced, potentially making mistakes. You can go back if you disagree, or you think, for instance, is this a mistake or is this an interesting outlier, which is what they're always looking for. The outliers might be the ones rather that they're looking for. So this type of experiments, schemas like we're trying to do in FAIR4ML are very much worth it. Right. Okay, I'll stop my rant and try to give you example of what I mean. So I only have 2 slides. This is an experiment in reproducibility for machine learning models at scale. And we have published this case study done with several other people and presented in a couple of conferences. So what we were trying to do here is to actually reproduce the results of a machine learning model that had been published in PNAS. That's the paper that you see on the top. And it was done by a colleague at another lab. And because it was published in PNAS, he wanted to make sure that not only the code, but the data was also accessible. And there's several, not only was also findable, but people could actually reuse his models and potentially find similar results. So the model is this adversarial super resolution model of climatological wind and solar data. So what they did is like they took this big climate model, E3SM, which has many different parts, and they used the model, and they were trying to bring it to a higher resolution, because the current resolution of these models, which I believe are like a kilometer, is not sufficient for local applications. So what they took the results of the model and designed a system to make it a higher resolution from the original data. And once they had these results, they decided to try to use a machine learning model to see if they could arrive at the same results with the machine learning model as they had previously with numerical reproducibility. And this is a common way of using machine learning in science, is that you have a ground truth, which can be either measurements done by instruments, like I mentioned before, or you can have computer data that is being produced by simulations and initial principles, and they call those ab initio calculations with certain, which have been designed with just equations. So the computer data gives us a ground truth. And then they're using machine learning model and trying to improve those to see if they can get to the precision and results that they're getting with the computer data. Or so in this particular case, it was a climate model data that they had obtained. So what they did, both in the simulation and in the AI model, was to actually downsize their data set and lower the resolution, and then of the climate model results, and then they would try to make it a more super resolution, that is increase the resolution using the machine model, the machine learning model. So the process was to decrease the resolution manually, and then try to see if the AI model could actually reach the same level of resolution that was in the original experiment. So and they published a paper in PNAS with all their data, test cases, data set, and the model itself, that it was very easy to reproduce. So what we tried to do is that we reuse this model with their training data, and we did this experiment first of all by retraining the model 1,000 times. We used the same data that they had, the same system, the same code, and we looked at the wind variable, which has 2 different angles. And this is what you can see in the diagram of RRMSE. and the numbers 0 to 1,000 are the results that each model would give with our retrained model on 1,000 times. And what you can see here is that the reproducibility was not at all achieved. The results were all over the place. In fact, this threshold, that is the blue line, that is 0.3 relative root mean square error threshold, is considered a fair performance, and only the results that are below 0.3 are fair or better. Okay, so if the so all the results that are above the blue line, and you can see there's a considerable amount of points above there, these results are not considered, they're considered poor, poor results. And we had used everything that they had put out, and they had themselves tried to make sure that as much data and code and metadata and instructions was available. So in other words, making it fair so people could reuse their models and reproduce their results. And it didn't work at all. I mean, the expectation was that even with these stochastics model, there should be much less variation if we have 1,000 runs and we retrain the data 1,000 times. So we contacted the researchers, and eventually with discussions, manual discussions, or email discussions with these people, they first of all, they urged us to use their new model, which the student had graduated by then, and it was no longer a possibility. But it turned out that some of their scripts for downsizing the resolution had not been included into their original software that they made available. And that was one of the reasons why we were not able to reproduce their results. Another part I suspected was that there were too few data sets that had been made available for the training, and not everything that they had used for training had been made available. So it ended up with having, so this experience in reproducibility to me points to the fact that we need guidance, even like the FAIR guidance is not specific enough to be applied to machine learning without, because even authors who wanted to make their data and their models fair so that people could reproduce them were not able to do so. And when we tried to do it, it didn't work. So that's why I think making the, developing the metadata schema and developing tools that can be used with it so that people who want to make their data and their experiments and their software fair can actually do so without so much of the non-trivial work that the person in the audience was describing, because I agree with you. I mean, it's like, if it's going to take more time and effort to develop, to fill out the metadata, nobody's going to do it. It's not worth it. And the scientists are certainly not going to do it. So we need the schemas and we need the tools to go with it. My second slide talks about all the challenges for FAIR in general and the reproducibility in AI ML, with more of the challenges related to FAIR on the left in the purple and blue bubbles, and the issues of computational reproducibility in the right side. So maybe I can concentrate on the left side. And the reason, if you want more reasons, more motivation for continuing and doing the work that we need to do for developing this schema. So with a model related, we have inherently stochastic models, we have random initialization, we have random splitting of training data, we have local optimization. That is, if the optimization is done only on certain nodes and not done on all the nodes. We might have incorrect Gaussian assumptions in the data. We work on a Gaussian distribution of data, but it might not be the case, in which case the model we're using might not be appropriate. and data related efforts in, as I have showed in the previous example with the documentation, the metadata, the provenance. There's the question of appropriate representation of the phenomena in the training data, which goes together with the incorrect Gaussian assumptions. And of course, data quality, data sparsity, mitigation, using AI for mitigation of data quality and data sparsity, and the appropriate use of synthetic data and transfer models. I mean, to what extent, if we use computationally produced data to train our machine learning models, to what extent are we going to reproduce, feed the data, the model with data that is incorrect due to some of those theory-related issues. So if you're interested in reproducibility and FAIR, and I also work, I mostly work in high-performance computing and scientific computing, you can visit the website on reproducibility, which is one of the projects that we're looking at, using the insights of that project inside the machine learning group. And I would be happy to entertain your questions, and thank you for your attention.
Okay, thank you. Do we have questions? Not seeing anything in the room. I don't see anybody else online who's asking a question. So I think, thank you then.
You're welcome. Does that mean everybody agrees with me, or does that mean that it's so far out, nobody wants to, far out in the sense of outlandish, that people don't want to engage? I'm sorry, you don't have to answer that question.
It doesn't appear that anybody is going to answer that question. Okay, all right. Let's see, so then at this point, this over. Is there anybody else either in the audience or online that has anything that they would like to contribute? Either kind of an experience, general comments, groups we should be talking to, or anything else? And let me, sorry, I also will, just for 1 second, you put this back on again as well. Okay, so just to say also that again, the notes and the slides with the links that are there, I noticed we had maybe 10 or so people say that they were here in the collaborative notes document. So if you wouldn't mind, we would appreciate it. I noticed that there were some comments from David in there that we might also want to talk about briefly. But I'll go to Hugh for the second.
Yeah, so just the one thing is that we have the FAIR consortium, which is going on there, and I'm always a little bit vague about how that connects. You know, this FAIR, the thing that Christine Kirkpatrick, yeah. So that's very much focused on the data rather than the model. Is that the distinction?
So yeah, so there's so in the US there's a project called FAIR, which stands for Fair, AI Ready, Reproducible, or okay, Readiness and Reproducibility. Thank you. Which I'm a co-PI of, so I should know the name of, but not completely. And it's under a NSF program called FAIR-OS RCN, which is basically fair and open science research coordination networks. David is PI of one of, yeah. So those projects are basically trying to encourage primarily people in the US to build up networks around different aspects of fair and open science. And so that one that Christine led specifically is looking at AI readiness, mostly focusing on geoscience data, a little bit on computer science data, and very little bit on everything outside of that. But it really is focusing on how to make the data AI ready more than anything else. So.
Having been to a lot of those workshops, I'll add that all those projects, there's also another one that's part of a US AI Institute, and Jane Greenberg at Drexel leads the data readiness part of that. All of them bleed over into the models as well because it's human nature.
Yeah, and so the one that Christine leads, we had a workshop in Washington, D.C. about a month ago or so, and I gave a talk about the FAIR for machine learning work at that. And there's going to be a meeting in January for all of the different projects to get together. And so it'll be interesting to see maybe this will come up as something that's kind of cross-cutting. Maybe it'll be more focused on data. I don't know yet. So. Any other kind of general questions, comments, contributions? I think so. I guess maybe I'll just say that David's comment that's in the collaborative notes, at least as I was skimming it, it looked like, in some sense, a question about use cases. I don't know if that's a complete way. Maybe that's just the part that I appreciated initially, but it does make me kind of wonder about if it would be worth trying to actually enumerate use cases at some point. And I kind of think that that could be part of Task Force 1. It's kind of implicit in Task Force 1 in some sense, the machine learning lifecycle, and then where does FAIR apply? I think in order to do that, we actually have to think about the use cases, but I don't know that we've written them down. And so I don't know, I mean, maybe that's a question for everybody else, is there work that has been done in thinking about use cases for FAIR and machine learning? Sorry, I'm just want to check the chat as well. So, okay, nothing there. Yeah.
A comment why such work does not really exist, or it's because the people who do FAIR don't do very much machine learning and the other way around. But there is a huge interest in making models comparable and results and everything. And I strongly believe that having a FAIR4ML model or whatever, improved model cards or something, will contribute to making these models comparable, because in certain areas we cannot track anymore the developments because they happen like on a daily basis, right? And we cannot check them. They are leaderboards, but that still doesn't tell me much about how good a model is. And the second one is because they are so dynamic, maybe we also want to think how to cite these model executions, because machine learning lifecycle, yeah, there are actually two phases. There is a training lifecycle, and then there is the execution lifecycle. I don't know if the current model captures that.
I think the model does capture that, but it kind of tries to put it together into one. So training is one aspect, execution is another, and then there's actually a bunch in between as well. So they're
trying to mix these two things, I think it's very, very dangerous, because training a good model, students, researchers must understand what the dangers are of not handling the data correctly. And if we mix them together, execution, training, we might introduce a lot of errors.
yeah, so I guess I can just say that I don't, I agree with you, but I also think from the point of view of the interest group, we kind of do want to have one life cycle and one model, but having it have components that have kind of sub life cycles underneath maybe would be a way of trying to do both of these. So maybe what we have is okay at a high level, but it needs a lot more detail within some of the individual boxes that we call a part of the life cycle. Maybe those really are, they have their own life cycles, and we should go into that.
So why my comment on this? Because absolutely all of the life cycles I've seen, non-fair related, not our things. They exclusively look at all the training process. That's the life cycle for them until they get and they train, they process the data, then they run another grid and search for parameters and I don't know what, and then they have the model at the end. This is what they see as a model life cycle. And I think for us, when we say FAIR4ML, we should look also further at the use of the machine learning model. That's why I would really like to have them separate.
Yeah, I think we're probably not saying things that are too different, but we're maybe it's just a question of scale or the level that we look at. So just for example, in here we have right, we have problem definition, data gathering, data pre-processing, method selection, model creation, model evaluation. I feel like that's a lot of what you were saying. And then we also have, well, and then model validation, but then we also have model storage and sharing, model use or reuse, model deployment and monitoring. So I think we have some of them, but we could definitely do them in kind of a different grouping and do them a little bit differently. And that I think maybe would satisfy what you're saying, and that might be useful to explore.
So I completely agree. I think it goes to attention that certainly in my group we find a lot, which is where we, grab FAIR, whether we're born FAIR, whether we're capturing things all along the way, and then who has the skills and the incentive to take care of different parts of that life cycle. And eventually, and we see that a lot at RDA, whereas I come from a domain specialty in material science, and I think a lot about everything that's going along the way. And then we have experts in digital libraries who are thinking of things as we have a data set for FAIR. Traditionally, we wrap it up and we take care of this long-term, moving from curation to stewardship maybe would be a way to think of it. And I think that here, since so much important work is happening along the way to get to that point, that you have to really grab both those. But I think there's always a tension there that we're still working out even as a group, in my opinion.
Yeah.
I would have a comment on a different note. So I'm a chair of the DMP Common Standards Working Group. So we were developing a common model to describe data management plans. So basically, it's very similar to what you're doing here. So having a group of people working on some terminology, creating a model and so on. And the problem was that when we produced the recommendations as a working group, many people were like, okay, great, but what do I do with it? Because it was a new thing. And I have a feeling this is more or less the same here. We're talking about the model, but then you have to tell the people of how to use it. And there are always, let's say, two options. One is how do I, let's say, generate this model? How do I fill it out? How do I create instances? What are the ways to automate it, for example? And the second one is assume I have all the information in the model. What can I do next? And maybe because if you have the generic life cycle, I know that this helps us in the group to communicate what are we doing. But then we are going to discussion in a little bit of the marketing, so to say. What are the three key options? I know reproducibility, comparing the models, auditability, trust, whatever it is, and then showing specific implementations would help in the adoption, basically.
Okay, so yeah, thank you. I'm trying to put some of this into an email that I can send to the co-chairs. Again, I would say anything that you've said that you feel like you really want to make sure is captured, if you can put it into the collaborative notes, and it doesn't have to be today, it can be anytime, right? Later this week is fine as well, or even probably next week. That would be very helpful because otherwise it's just, there's some danger that the discussion just gets lost after the meeting. I will say, sorry, just for David, I don't know what our agenda is exactly, how full everything is and how set everything is for the January meeting, but maybe it's worth thinking about if we can get a little bit of this discussion in there as well, because this might be useful to continue with, so. Okay. Okay, so. Okay, okay, right. All right, sorry, that's a little bit of a side discussion because that doesn't apply to everybody, but. Yeah, so the hackathon is online and it's through the end of the month. And it's through the link that's in the, you can get to everything through that link. So, in the slides. Okay, so let me wrap up. I actually thought we were going to end early, but we'll try to end on time. Oh yeah, so this is right. So the link is to the hackathon. Okay, so the last thing to talk about is just kind of these general questions about, again, as I said, we've been doing this as an interest group with these task forces, kind of like mini working groups, but not exactly. Are there other task forces that we should be starting? And I think use cases around machine learning, maybe that actually should be a separate, around machine learning and fairness. Maybe that should be a separate task force and it shouldn't be part of one. I don't know. I think it's an interesting thing to discuss. Again, if you have ideas about other things that would make sense, particularly if there's something that you wanted to lead even, that would be great. Put them into the notes. Yeah, I think that's that part. Again, I'll just repeat this from earlier, but you can join the RDA group by going to the RDA website, assuming that it has this functionality now, which I think it does. Signing in and finding the group and then joining the group. And that puts you onto the mailing list. Monthly meetings, even months at 8 UTC, odd months at 20 UTC. We send reminders once you're on the mailing list, so you hopefully will be able to join. You can join the task forces and you can work on the documents asynchronously, including the online hackathon for the metadata through the end of the month. And maybe I'll just say finally, we have, I don't know, 15-ish, 20-ish people kind of here, maybe 25 online as well. It's a pretty small group of people. This is a pretty big problem. So if there are other people that you know that would be interested, kind of help us bring them in. If you know other people that should be involved in the hackathon, kind of point them at it as well. And if they want to participate, that would be great. And with that, I will say on behalf of Curtis and I and the other co-chairs who aren't here, or Lynn who is online, thank you very much. And I don't actually know what's next in the program, but there must be something at 11:30. So.